Thank you for taking the time to join us for this session. My name is James Meyer. I'm the Data Analytics and HPMS Manager at the Arizona Department of Transportation, and I'm joined today by Carol Francis and Bo Guo from Gistic Research. To give a little background on what got ADOT into this effort, as many as you may know already, ADOT completed our roads and highways migration back in August of 2014. This made us one of the first, if not the very first, DOT to go live with new roads and highways LRS tools in the nation. For ADOT, our early adoption of roads and highways and culture of continuous improvement has positioned us to be a leader in driving a department-wide data culture revolution. At the foundation of this revolution is providing quality data, analytical tools, but also following sound data management and governance practices driven by GIS and linear referencing. The data review and visualization project started about 2 years ago, which led to bringing in Gistic Research for its expertise in linear referencing-based data integration and visualization. The project started with an in-depth review of major data items ranging from HPMS, bridges, pavements, assets, and safety, which not surprisingly discovered many of the things we have known for years about our data. We have silos. After all, who doesn't have siloed data systems? Who has perfect data, or who makes metadata a top priority of their organization? The conventional wisdom on silos is that they are to be destroyed, consolidated, or replaced. We have been talking or even trying for over 20 years as an organization towards that goal. But let's face reality, we are seeing more silos today than ever before. This is because of Conway's Law, and that the silos are a product of our organizational structure and/or funding models. We decided to change strategies and connect the styles instead of ostracizing them. What do we use to connect the data silos with? Well, you guessed it, it's LRS, which leads us to the notion of silos of hope. Now, let us take a look at a couple of dashboard themes. Carol, will you walk us through the journey of Tableau dashboards to the addition of ArcGIS dashboards and expose what we have seen so far?
Thanks, James. Hello, my name is Carol Francis. I am a GIS analyst with Gistic Research, and I will be talking to you about dashboards and data visualization. The ADOT data visualization story started with Tableau. We were initially pleased with Tableau's ability to display non-spatial data and happy to have found a way to embed Esri story maps within our dashboards. This tabbed dashboard displays Highway Performance Monitoring System, or HPMS, data. Tabbed dashboards follow the HPMS theme. If I click the More Information button, I can access some embedded story maps that provide a wealth of information and metadata about the data displayed on the dashboard. As GIS pros, we were underwhelmed with Tableau's mapping capability, so the team started searching for alternatives. This led us to ArcGIS dashboards. I was thrilled to discover ArcGIS dashboards. I found the interface to be intuitive and straightforward and a lot of fun to work with. What you see now is an Esri story map that we are using to organize dashboards and metadata in a theme. The second tab contains a dashboard that displays maintenance ratings for various structures in Arizona. The widgets interact with each other, so if you want to examine state-owned culverts that were inspected in 2018 in Maricopa County, clicking on the corresponding selectors and graphics will narrow down what is displayed. The user may obtain more information about an individual structure by clicking on a point in the map. If a user wants to learn more about the bridge ratings, they may simply click on More Information on Structures and NBI to access an informational story map that is embedded in the tabbed story map. This story map serves as an advanced metadata technique.
Thanks, Carol. The initial dashboard opened our eyes to what is possible. But at the same time, the dashboard exposed something we could no longer sweep under the rug. After all, the enemy of good data is trying to put it to use. Bo, who leads the project at Gistic Research, will take it from here.
Thanks, Jim and Carol. My name is Bo Guo, Carol's colleague at Gistic Research. I love to tinker with architecture and design of GIS systems and applications. Perhaps not alone, ADOT has metadata shrapnel scattered in its digital landscape, such as in feature classes that are haphazardly managed through our catalog, or in documents in God knows where drives. Not surprisingly, some metadata existed only in a non-digital format we are all familiar with, human brains. The review phase of the project concluded what we were lacking was a metadata system more than metadata information. A system that managers and data owners could update in the one and only place from which the one and only authoritative version of metadata was consumed or propagated. So we built the metadata repository inside the NPD Data Mart, along with a metadata maintenance application to allow bring dumps to happen in a controlled fashion. The metadata repository is consumed by various dashboards, which you shall see. We're looking for ways to update metadata in Esri feature classes through automatic synchronization. If anyone has any suggestions or solutions, we appreciate you sharing with us. About a year ago, Jim proposed the concept of data quality and authority measurements. We were unprepared for this new challenge, nor could we find any suitable quality measurement framework. But together, the database team pioneered Data Quality Index, or DQI, as part of the metadata system. In the interest of time, we will only point out a few key design features. We can discuss details offline if anyone is interested. There are about a couple dozen evaluation components that are grouped into 3 sections. The source section is to measure authority and timeliness. The process section is for fidelity and sustainability, and the QC section is to gauge confidence. This slide shows a few sample components under each section. Each evaluation component is either qualitative or quantitative in their score type. A qualitative score has a value of 0 or 1. A quantitative score can be 0, 1, or 2. Score can either be assessed by data owner or calculated via a process under a set of predefined rules. An LRS layer's DQI score is calculated in 3 steps. Section score is calculated by multiplying the qualitative scores by the summation of the quantitative scores. Layer score is obtained by summarizing the section scores. The final step normalizes the score in percentage terms. The ADOT DQI system is designed to be open and adaptable to meet pretty much any requirements. However, the system does not measure positional accuracy. I'm turning over to Carol for a metadata demo.
This is the Metadata Sources tab of our QA dashboard. Here you see information about where this data is used and stored and who is responsible for this data set. In the center of the dashboard, you see the quality score, which is a calculated value that helps us quantify the quality of our data. We rate the quality of each data set in many categories. These scores are a combination of calculated and manually entered values with 2 scoring ranges. Qualitative scores have a possible range of 0 correlating to poor to 1 correlating to good. Quantitative ranges have a possible score of 0 correlating to poor, 1 correlating to fair, and 2 correlating to good. The shape and color rankings are a colorblind-friendly variation on the familiar red, yellow, green traffic light symbology. Following the theme of this dashboard, the user is able to use the source data dropdown to cycle through the different data sources.
The DQI has shown that there was work cut out for us. we needed to dive deeper at the individual row level to fix data issues. We have built dual-track QC processes using FME, Esri Data Reviewer, and ArcGIS. Here is the ArcGIS-based QC process flow with Data Reviewer, Event Editor, and ArcGIS dashboards. Let me turn over to Carol once again to help us visualize a few QC scenarios.
This is the Temporal Analysis tab of our Tableau QC dashboard. This dashboard visualizes temporal errors in our spatiotemporal data. On this graph, the x-axis displays the route measure, and the y-axis displays the temporal extent of the event. In this example, there is a temporal gap in the data on Interstate 17 between the measures of 20.7 and 21.05 miles. This temporal gap was caused by the blue events that occur before and after the gap. A data editor may click an event in the viz to open the event in RCE to fix the problem with the data. This ArcGIS dashboard displays quality errors in our LRS network. The data that feeds this dashboard was generated with error checking tools including Esri Data Reviewer. The bar charts summarize quality issues both by segment count and segment length, as do the pie charts. The viz elements interact with each other. If the user is curious about events with invalid or null geometry, they may click invalid or null geometry in any of the graphic elements. Furthermore, if the user wants to investigate route errors in a particular region, they may zoom to that area on the map and the graphs will reflect route errors in that region. Here, I will zoom to the Metro Phoenix area. Notice the bar and pie charts reflecting the change in extent. Furthermore, if the user wants more information about an error on a specific segment, they may click the segment on the map.
The exposure of the data bugs has led to searches for causes and solutions. Being among the first in the nation to implement roads and highway 5 years ago, we have accepted the fact that data shrapnels from the legacy systems may surprise us from time to time. The DataViz team plans to review and improve LRS maintenance workflow in light of the latest best practices. At the same time, we have been working on ways to enhance LRS maintenance experiences. This leads to our final demo of Linear Bench Event Ninja, an ArcGIS web application designed to make event editing more efficient.
Linear Bench Event Ninja is a web application built on top of ArcGIS Enterprise to help maintain LRS events in roads and highways. Ninja's UI is composed of a menu bar, filter map pane, tabular pane, and time-space diagram, or TSD. The Explore mode allows the review of filtered events in different but synchronized ways. A typical Explore session starts with the filter pane where you can pick your LRS layer and optionally your route, set up or even manage your version, use the map view to set your area of interest, change the date of observation to explore the historical state of the LRS layers. The user can switch LRM from referent to measure. A selected event row is called a primary row. Its topologically related events as topo rows are collected and are accessible just below the primary row. The TSD contains a stick map showing the route and intersections. The TSD draws both the primary event as well as the adjacent events. Topological issues of gaps and overlaps are visible in the TSD. You may also move the timeline to see if there have been any visible route changes. The Update mode allows for editing transactions with temporal significance, such as update, insert, or retire events. One or more event can be edited, providing they have the same effective date, which is a required item in the Update mode. A user can conduct update edits in the card view, including changing segment definition. For example, a user may change from referent and adjust offset. However, TSD, with its snapping capability, offers a more intuitive and less error-prone alternative in avoiding topological errors. The correction mode allows event corrections without impacting their existing temporal state. Maintenance is for doing split or merge operations. The color of the menu bar changes as a user switches to different modes. This serves as a friendly reminder of the Ninja mode a user is in. Linear Bench Event Ninja is a logistic research project inspired by the growing adoption of Esri's roads and highways in DOTs around the world.
At this time, I'd like to thank Carol and Bo for helping to provide this presentation, and to all of you who took the time to learn about what ADOT is doing with data visualizations. And at this time, please go ahead and share any questions you have with us, and thank you very much.